Hello, Algebra 1 students, and welcome to Lesson 1.4. Our objective today is I can simplify expressions containing exponents. So we're going to review some of your exponent rules, and then we have 3 examples on how to simplify expressions containing exponents. So let's keep going. Alrighty, so we had talked about this a couple weeks back when we were talking about order of operations, but as a reminder, the power is an expression written with an exponent and a base, or the value of a such expression as 3 to the second. So 3 is your base number, 2 is your exponent. So that means then that 3 is the number you're continuously multiplying. I'm going to multiply it twice or by itself too. So I'd write it out 3 times 3. Okay. The number is raised to the second power. We use it as squared. The area of s times s is s squared. So that would be if you're finding the side length of a square. That's why they call it squared. When a number is raised to the third power, we call it cubed, because if I was going to multiply these side by side and then by side, I end up getting the volume, or what would be the cube. And so that's why anything to the second is called squared, and anything to the third power is cubed. At least the terminology for math in this. All right, so here are our first examples. So this is example 1, writing powers for geometric models. So write the power represented by each geometric model. So this is a lot like what I was just saying if we've got squared or if we've got cubed. And notice that looking at these pictures, they're very similar to looking at these pictures. So basically, I want to make sure I know how many dots or squares are in each one, and then figure out what number to what power would give me that. So in this case, if I count all these up, it looks like I have 9. And so to get 9, I would have to have 3 squared. That is the only thing to a power other than 9 to the power 1 that would give you 9. So in this case, I have 3, and it's a multiple of 3. 3 times 3 gives me 9. This one, though, or you can think of the side times side, like I was saying, side and side. So 3 times 3, that's how you get the 3 squared. This one is a cube, and just like in here, that means that we put it to the power of 3. So let's see what our side is. And let's make sure it's a square. So this is 4, and this is 4. So in this case, I'd have 4 to the third. 4 to the third, let's see. I want to see what this one, we just need to write the power represented, but I'm curious what 4 to the third is. So 4 times 4 is 16, times 4 then, 64? Yeah, 64. But keep it in the terms of the power. So these are your solutions. All right, so there's no easy geometric model for numbers raised to exponents greater than 3. So we don't have like cool words for anything. It's basically what they mean. There's no words or geometric models or pictures that go above 3. So you can write them out using repeated multiplication. So just kind of repeating the same thing that repeated multiplication. So if I just had 3, it's 3 to the 1. 3 times 3, well, there's 2 3s, so it's 3 to the second. There's 3 3s, so it's 3 to the third, or 3 cubed. There's 4 3s, there's 3 to the 4th power. And then there's 5 3s, so it's 3 to the 5th power. And so that's just how we write it out, as well as kind of in your word form, how you show in multiplication, how you show it in power, and what the actual value is. Again, feel free to pause the video at any point if you feel I'm going too fast, or if you think maybe a chart might be helpful for you to write down for future reference. Feel free to always email me or let me know if you've got questions. You can always visit me during office hours as well. Or we can catch up tomorrow when we're doing our assignment together. Alrighty, example 2, so evaluate powers. Simplify each expression. In this case, I want to actually find what the value is for this expression. So what does this really mean? So in this case, and we can rewrite them out or we can expand them. And in this case, it's like I've got a parentheses with a -2 to the third. If I was to expand this, it would look like this. I would continue with the parentheses as I go through. Is being multiplied 3 times. That's why there's 3 -2's. So if I actually solve this out, so if I think first -2 times -2, that's a +4. But then +4 times a -2 gives me -8. And so that's what they want me to do when I simplify each expression. It's just actually finding what is -2 to the third. Now, in this case, so there's a difference writing it between like this and this. So this one is now also negative, but this one does not have parentheses. And so if I actually expand this out, it looks like this. Or in this case, no matter what power it's raised to, your answer is always going to be negative. So I think, okay, what's 5 times 5? 5 times 5 is 25. So I have a 25 in the parentheses, and my final answer would be -25. In the case of A, if instead I had it -2 to the 4th power, it would look like this. -2 times -2. We'll just keep going times -2 times -2. Remember, -2 times -2 is 4, and if I do it on this side too, it's 4. 4 times 4, well, now I get a positive number. So in the case that you have parentheses, this is a really good hint and to help you remember, so I might suggest writing this down. Actually, I'd highly write this down, is that if you have a parentheses and it's raised to an parentheses with a negative, let me rephrase that. If it's parentheses with a negative and it's raised to an odd power, odd will give you a negative solution. But if it's raised to an even number, it will give you a positive answer. That only works though if you have the parentheses there. Okay, in this case, you have no parentheses, so it's automatically going to be negative. No matter if it's an odd power or an even power. All right, so and then C, though I want to rewrite this. So in the case of C, what you end up doing is you treat it like 1 power for each part of this fraction. So I would take 2 to the second. 2 to the second is 4. And then 3 to the second. Again, we keep it in the fraction. So we have 4/9. 4/9, there's actually no way that I can simplify this, and so it just stays as 4/9. And that is my solution, or my simplified answer. Alrighty. Again, I'd write this down. It'd probably be really helpful to remember, but also you can write it out too. Alright, I'm going to continue on. Alrighty, and we actually have one more example. There's actually 4 examples in this lesson, but I'm going to skip example 4 and we're going to talk more about a problem like that when we go through the work for this this lesson. So we're just going to do example 3 here, and that will be the end of your video. So example 3 is writing powers. Write each number as a power of the given base. Code word is turtle. I'm not always going to do it at the end, but maybe I will. Turtle. All right. So what we need to do is write each number as a power of the given base. All right. So basically, it's a really weird. I'm not a big fan of how they give the directions. But basically, we have a base of 2 in this first problem. And they want our answer to be 8. And we need to figure out what is the exponent, is what they're meaning here. So if they ask you to write each power number as a power of the given base, here's the solution or the answer or the value. This is the base. We need to find what is this exponent. So let's think. I've got 2 times 2 would give me 4 times 2. That gives me 8. So my power is, or my base is 2. There is then 3 2's, so I'd have 2 to the 3rd as my answer. All right, B is going to be a little more tricky though because we've got a -5. So we could, there's actually a couple ways you could write this. Pretty sure. First, let's forget about the negatives for a minute and think about multiplication. So 5 to the power of what? Power of what? And again, I'm just forgetting about the negatives for just a minute to see if I can make this work, okay? Then we'll think about those rules that I were just talking about odd and even and making sure that we can keep it negative. 125. So let's think. 5 times 5, that's 25, times 5, that does give me 125. So one way you could write it, because I want it to be negative, is you could keep it with a parentheses 5 to the 3rd. Because remember, if it has an odd number here, that means your solution or your answer is going to be negative. But you could also write it as -5 to the 3rd, because that will always be a negative answer. So either one of these would work as your solution. You don't necessarily have to have both. You could if you would like to, but as long as you have one of those answers, you got it correct then. All right, that was it for this part. If you've got any questions, let me know. I will be doing office hours Tuesdays and Thursdays in the afternoon if you need me. Otherwise, always shoot me an email or reach out to me the next day when we're working on the assignment for this. Otherwise, have a good rest of your day, and I will catch you guys next time. Bye.